Robin. So we're going to solve question number 35 of the GATE 2019. Now I would like to say this is actually a very tricky question. Tricky in the sense because people will be bound to make mistakes because of the expression they remember. They won't fully read the question and they will choose a very incorrect option which they will think that is the right. So I'll tell you what is the mistake that you are bound to make in this question, because you must have gone through spin orbit coupling derivation for the hydrogen atom, and you must be knowing this, like what would be the form of f of r in this form of the spin orbit Hamiltonian if you have electron in the hydrogen atom. But there is a catch in this question. What they have asked is if the electron moves inside a uniformly charged sphere. It's not the hydrogen atom problem. So you'll be bound to make mistake because of the things you remember. So I'll tell you both things, what option you might be prone in selecting and what is the actual option which you have to select. Okay, so let's start. So what is if you have any sort of potential as a function of V of r, you have a central potential. Your spin orbit term is basically E by m square c square 1 by r dv by dr, right? I mean, there must be some factors over there, but we are mostly interested in the dependence on r. So this is the term which is more important to us. Now, in case of hydrogen atom, what is your V? It is minus Ze by 4 pi epsilon r, right? Okay, this is the Q. Okay, so in that case, your dV by dr is proportional to 1 by r square. So your HSO term will be 1 by r cube times L dot S. So that is the option which people might select, this one, which is wrong. And you will also remember, most of the people have remembered this expression like this. This is the dependence. And you'll be like, oh, I should select this option. But you should read the important part of this question. If your electron moves inside a uniformly charged sphere, that's the part. For that, you should know some electrodynamics, your electricity and magnetism course. Okay, so the only thing you would basically remember is what is the electric field for the uniformly charged sphere. If you have a uniformly charged sphere with a rho density at any point r. So there are two cases when r is greater than r. You would remember it is k, which is 1 by 4 pi epsilon naught q by r square, and inside the r it is kq r by r cube, right? That's how you remember this. Okay, if you convert this to V, how would you convert that to V? For it would be, for if you look as a function of r, it would be kq by r for r greater than r, but it would be this thing. Now, how did you get this? I'll give you the idea. So for r greater than r, V has to be from minus in infinity to r, right? This is nothing but kq by r. For a less than r, it has to be from infinity to r, which is kq by r square dr. But for the inner one field, it has to be r to small r, which is inside, and you have to use the field which is inside. Okay, so if you do this thing, you'll get first term this, and you'll get second term this. Okay, so that whole thing will give you the expression which has a dependence on r square. Now that is something which has been asked to you in this question. Now let's say this uniform charge is minus Ze, okay? Okay, so what would be your dV by dr? It would be first term 0, right? It's a constant. So second term would be KZE by 2R 2R cube, which is KZE R by R cube. So if you look at 1 by R dV by dr, which is nothing but a constant of this order. So in this case, your f of r would be proportional to a constant. So it has to be option A. So that's why I was saying you have to be very careful while you're selecting a correct option. Okay.